All right, you guys, let's continue our discussion on polar equations by doing the following example. So part A says, give 3 other pairs of polar coordinates for the point 3, 140 degrees. Okay, so anytime I'm asked to give another coordinate for the same one that I have, I will plot the point that I've originally been given so I have an idea of where it is. All right, so let's do that. So remember, we always start along the positive axis, okay? And we're going to rotate first. So our theta for this problem is 140 degrees. So 140 degrees would be here. And our R tells us how far out we're going to walk from the center or the origin. And I'm going to walk out 3. So 1, 2, 3. This would be my coordinate. Okay. Now, when they're asking us to find 3 other pairs of polar coordinates, you can think about this like a GPS system, okay? So typically when you plug in an address into your GPS is going to give you the most efficient, quickest, fastest way to get there. So in terms of our polar system, this point, 3, 140 degrees, that's the quickest way to get here. But it's not the only way, okay? So if I want to look for some more points, some other ways that could get me there, all right, so our original point was 3, 140. Okay, well, if I wanted to come back around to this same angle, okay, we know that angles, we can find the coterminal angle, which means that we could add 360 degrees to this, right? And we could come back to the same point. So we could find its coterminal. So if we took 140 and we added 360 to it, that would give us 500. So I could say the same point could be achieved by saying 3, 500 degrees. That could bring me to the same point. Okay. Now, another way that I could get there, all right, let's say I wanted to go along this ray. This one here. So the one that's diagonal from it. Okay. So let's say I go 320 degrees this time, okay? Now, when you're in the polar system, you can walk backwards, remember? So if I rotate to 320 degrees, I wouldn't want my person to walk along this way. I would want them to walk backwards to get back to the same point. Well, I still need them to walk out 3, but remember, anytime you need them to walk backwards, your R is going to be negative. So that could bring me to the same point, okay? Now, instead of walking 300 or rotating 320 degrees, I could also move a negative angle. So let me change my color. Okay, so let's say I didn't want to rotate a positive angle. I wanted to rotate a negative angle to bring me back to the same point. Well, instead of saying 320 degrees, that's the same thing as saying negative 40 degrees, okay? And if I brought back to this point, okay, I still wouldn't want to walk along this ray. I would want to turn around and go backwards so that I end up at the same point. So R would still be negative, okay? So as you can see, there are hundreds of possibilities for the angles that I could come up with. I could continue to find coterminal angles. I could differ between my R being positive or negative. There is no restriction on how many points that you could get. So there's no one right answer to get this unless your directions restrict how large your angles could be. But you could use negative angles, positive angles, and change between your R being negative or positive. So these are my 3 angles. You could come up with different ones. It's completely up to you. Okay. All right, let's look at B. So B says determine 2 pairs of polar coordinates for the point with rectangular coordinates -1, 1. Okay, so let's flip this. All right, so for B, this time we have rectangular coordinates. Okay, so if you guys remember those conversion factors that we looked at earlier, okay, remember when we were converting from polar to rectangular? Okay, so our other 2 conversion factors that we had, we were given these equations, r squared equals x squared plus y squared. And we were also given that tangent theta equals y over x. okay? So these conversion factors allow us to take our rectangular coordinates and change them into polar, okay? So because this is an xy coordinate, my first coordinate is x, my second one is y. So if I'm looking for r, I can plug these values in. So r squared is going to be equal to -1 squared plus 1 squared, which would be 1 plus 1. So r squared equals 2. But I'm not looking for r squared, I'm looking for r, so I would square root both sides. So r equals the square root of 2. And I'm looking for my theta to complete my polar coordinate. So I could say that tangent theta equals, my y is 1, my x is -1. So tangent theta equals -1. And I'm looking for theta, so the only way I can get theta out of there is to do the inverse. So I'm looking for an angle that has a tangent value of -1, and I could say 135 degrees. So an equivalent point in the polar system for -1, 1 would be square root of 2, 135 degrees, okay? Now the directions said they wanted 2 pairs, okay? So another point that I could get, I could add a coterminal angle to this. I could add 360 to this to get the other point. So I could say square root of 2 and then 135 plus 360, 495. That would bring me to the same point. I could also use a negative angle. So I could also say square root of 2, -225. Okay, and you could get -225 because you know that tangent is negative in 2 quadrants. Tangent is negative in the second quadrant, and it's also negative in the fourth quadrant. So I could use this, and I can move backwards. Okay, so any angle that's coterminal with 135 degrees would have worked. Okay, cool.